Hi everybody. Today we're going to have a little look at conditional probability. It's quite a short look at it. It's a big topic. And let's start with what conditional probability is. It's something that restricts the scope of a problem being considered by reducing the size of the sample set. So here's a sample set. I'll just give myself the right pointer. Here's a sample set. Inside A we have 9, inside B we have 7, inside the intersection we have 4, and outside here, outside of set A and B, we have 8, giving us a total of 20, hopefully, if I've added up correctly. What we're going to try and find is this thing, probability of A given B. This slash here we say is given. And try and determine what that means. So let's start with the second part. This part here is saying we're going to restrict what we look at just to B. We're going to ignore everything else. And the question is, find out what part of B is A. So that kind of looks like this next Venn diagram. We're going to ignore A only and the outside because we're only looking at B. Here's B here. And we're going to find the probability that this part here, the bit that's still in A, is selected. So we're going to look at out of the whole 7, what's the probability of picking the A bit, which is 4. So logically that's 4 out of 7. Similarly, if we're looking at B given A, which is this expression here, we're going to restrict the sample space to just A, and we're going to find the probability that the B part's in it. Okay, so here we go. Here's just A. And here's the part of A that's B. So it's the B circle. That bit's in B, because we're ignoring these two sections this time. And so that's the 4 out of the whole 9. Now, funnily enough, we can summarize PA given B as the intersection part of A and B, so that's the intersection between the two sets. In this case it's the middle, divided by the number of elements in B alone, which would be this part here. Well, actually we're dealing with this diagram, so where am I? Probability of A given B, so we just look at B, and the intersection of those two, which is that part there, divided by the whole of B. Divided by the whole of B. Okay. Once we understand this statement, we can find the solution to PA given B by just looking at the original Venn diagram and not having to redraw it with just B. So, PA given B is the number of elements in the intersection, well that's 4, divided by the number of elements in B, well that's 7. There you go. We didn't have to redraw anything. Similarly, if we were looking for not A given B, we would look at the intersection of not A and B. So the intersection of not A would be out here. Sorry, not the intersection. Not A would be out here. B would be here. The intersection between those two sets would be just B only. And divide that by the number of elements in B. So that's B only. B only would be 3, B would be 7, the answer would be 3 divided by 7. Cool. Now we could also do that with a two-way table, remembering that the elements in the middle here, this is A intersection B, this is B intersection not A, this is not B intersection A, this is not B intersection not A. This value here is the number of elements in B. This is the number of elements in not B, this is the number of elements in not A, this is the number of elements in A, and that's the total elements in the set, the number that I typically put here on the outside. So, if we wanted PA given B, we'd find the intersection of A and B, which is just this number, divided by the number of elements in B, which is that number, we'll get 2 divided by 5. If we want the probability of not A given not B, so not A would be, On the top, we need the number of elements of not A intersection not B. Well, not A, not B, that's the intersection. There's the 6. Divided by the number of elements in not B, which would be 10. But give it 6 over 10 or 3 over 5. So that's the mechanics of it. Let's see if we can apply it to a problem. We have a sample size of 20. It's students being picked up from school and students that buy lunch. So we know that, I might rub this out and do the first part with you and then work on the second part. The sample size is 20, stuck 20 down here. Number of students being picked up is 10, that's this P down here. Students that buy lunch is 15, here it is over here. And students not picked up and don't buy lunch, that's what that's supposed to say, is 5, that goes here. Once I do that, I can start to fill the two-way table in. That will be 5, that will be 10, that will be 5, that'll be 0, that'll be 10. Okay, done. And we did some of these in an earlier exercise. Now what we want to find is the probability that they're picked up given that they don't buy lunch. So that would be this expression over here. Picked up intersection don't buy lunch. Now picked up don't buy lunch, that's going to be 0. We're going to divide that by not L. Not L is 5. 0 divided by 5 is 0. So that isn't going to happen. What about not picked up by lunch? Well, the intersection of not picked up and lunch. Not picked up and lunch is 5. The number in just lunch alone, lunch is 15. Divide those to get our given statement. Not picked up intersection L is 5. L itself is 15. Divide them, you get a third. And there are some conditional probability statements. Now we do a lot more with them than this, but this is a little bit of an introduction to it, and I hope that understands specifically what this given operator does. Thank you, everyone.